In a locked glass case in a museum in London sits a small cylinder of pink granite, no taller than a coffee cup. It was drilled out of solid stone in Egypt more than 4,500 years ago. Wound around its surface, from one end to the other, is a single spiral groove, as clean and regular as the thread on a screw. That groove is the reason this video exists. Because the way it was cut should not have been possible for the people who made it. They are supposed to have worked with copper tools and stone hammers. Nothing that spins fast, nothing that vibrates, nothing hard enough to carve a smooth, winding channel into one of the toughest rocks on the planet. And yet the channel is there. You can run your eye along it. And when the first modern scientist to study this object sat down and measured it, he did not find a simple answer. He found a detail that runs backwards. The groove bites deeper through the hardest crystals in the stone and shallower through the soft ones. That is the exact opposite of what grinding or rubbing should ever do. When you wear away rock with sand, the soft parts go first, and the hard parts stand proud. Here, the hardest mineral in the granite was cut the deepest, as if it offered the least resistance instead of the most. The man who measured it was not a mystic. He was the most careful surveyor of his age, and he wrote in plain language that this feature could not be explained by any loose powder at all. That is where this begins. Not with a theory, with an object you can walk up to and photograph, holding a mark that the standard story of ancient Egypt cannot cleanly account for. And here is what makes it worse. The tool that cut this core has never been found. Not a fragment, not a drawing on a wall. We have hundreds of the cores and the holes they came out of, scattered across Egypt, but we have never once recovered the thing that made them. It is as if the method left its signature everywhere and then vanished without a trace. This is not one strange object. Across Egypt, there are holes bored clean through blocks of granite. There are saw cuts running through stone that weighs as much as a truck. There are boxes hollowed out of single blocks with interiors so square and so flat that they read like machine work. And every one of them was made by a civilization we are told had barely stepped out of the Stone Age. Today we are going to follow three pieces of evidence. A written account from 1,000 years ago that describes moving these stones by striking them. An account everyone files under fairy tale. A modern industrial process that leaves marks almost identical to the ones on that core and runs not on brute force, but on vibration. And a satellite survey flown in this century that looked down at Egypt and proved the operation was far larger than the monuments we can actually see. Stay with me, because the part that should unsettle you is not the wild theory. It is the plain fact sitting under glass in London. For most of the last century, that little cylinder sat in a drawer and almost no one talked about it. The detail was printed in a book, in plain words, by the founder of scientific archaeology in Egypt, and the field mostly walked past it. Then, decades later, a working engineer read that same description, went to the museum, and came away convinced that the marks pointed to a technique we did not invent until the 20th century. Mainstream Egyptology rejected his conclusion, but notice what the rejection still has to explain. It has to explain a tool that was never found, a groove that cuts backwards through the crystal, and a level of precision that repeats across hundreds of miles and thousands of years. The question is not whether the Egyptians were skilled. Everyone agrees they were. The question is what, exactly, they were cutting stone with. And that question has never been answered. Start with the account everyone laughs at. In the 10th century, a historian traveled the known world and settled in Egypt. He was so respected that later writers called him the Herodotus of the Arabs. He wrote a history in dozens of volumes, and when he came to the pyramids, he recorded something strange about how the stones were said to have been moved. According to the account he preserved, a sheet of papyrus inscribed with certain characters was placed beneath a block. Then the block was struck, and with each strike, the stone lifted and traveled the length of a bowshot before settling again. And the process was repeated, strike by strike, until it reached the site. For 1,000 years, that passage has been treated as pure legend, magic paper, enchanted stones, nonsense. And, taken literally, it is nonsense. But strip the magic away and look at the mechanism the story is actually describing. It is not describing ropes. It is not describing ramps. It is describing a stone that is struck and that responds to being struck by moving. That is a description of percussion, of vibration, of sound applied to stone as a working force. Whoever first told that story remembered a method that centered not on hauling, but on striking, not on muscle, but on resonance. And this is not the only culture that did it. In legend after legend, from more than one part of the world, the largest stones are moved the same way. Not with wheels, with sound. By chanting, by striking with a rod, by drums and horns and tuning. The details are always dressed up as magic. The core image is always the same. A hard stone, a sharp sound, and a result that muscle alone should not be able to produce. For decades, scholars dismissed all of it as superstition. But keep the image in your mind, because when we reach the third clue, a modern machine is going to do exactly this, in a laboratory, on purpose, and no one is going to call it magic. That is the second thing to hold on to. The first is still the core. In the 1880s, an Englishman named William Flinders Petrie went to Giza to do something no one had properly done before. He measured it. Petrie is now called the father of Egyptian archaeology because he brought real precision to a field that had been half treasure hunting. He recorded everything down to a fraction of an inch. And among the fragments he collected were drilled cores of stone, the solid centers left behind when a tube drill bores a ring into rock and lifts out the plug. Many of them are still kept in the museum named after him at University College London. The most famous is catalogued as number 7. The researchers who argue about it just call it the infamous Core 7. Petrie was an engineer by training, and what he saw on Core 7 disturbed him enough that he tried to explain it 3 separate times in a single chapter of his book. 3 features made it, in his words, an impossibility under any ordinary theory of Egyptian craft. First, the hole and the core were tapered, the kind of taper you get when a drill wears down as it cuts. Second, a symmetrical spiral groove wound around the core, and from its pitch, Petrie calculated that the drill had sunk into the granite at 1/10 of an inch with every single rotation. He compared that to modern machines and found it staggering. Modern diamond drills, turning hundreds of times a minute, bite into granite far more slowly than that groove suggests. Petrie wrote that next to the Egyptian cores, modern diamond drill cores looked like clumsy, smudged work. And third, the detail we started with. The groove ran as deep, and in places deeper, through the quartz as through the softer feldspar beside it. Petrie spelled out exactly why that mattered. If the cut had been made by loose grains of sand, the groove would have to be shallower in the harder mineral because loose sand wears the soft parts faster and leaves the hard parts standing. Instead, the groove plowed straight through the hardest crystal in the rock, as though hardness barely slowed it. He described the spiral as a groove that wound down the core like a drunken screw, and he concluded it could only have been made by fixed cutting points driven under enormous pressure. The mainstream explanation for these holes is a copper tube spun by hand, fed with wet quartz sand, grinding down slowly over many hours. And for a great deal of Egyptian drilling, that explanation holds up perfectly well. But it runs straight into Petrie's third feature. Loose sand does not plow deeper through quartz than through feldspar. It cannot. The physics runs the other way. So either the founder of the entire field misread a simple object, which almost no one who has examined the core believes, or the tube and sand story is missing a piece. So what kind of process cuts deeper through the hard crystal than the soft one. There is a family of methods that does exactly that. And it is not ancient. It is modern. It is called ultrasonic machining. In a modern shop, you take a tool bit and you make it vibrate, not spin, up and down tens of thousands of times a second. 19,000 to 25,000 cycles per second. Faster than the ear can hear. You press that shivering tool against a hard, brittle material, feed an abrasive into the gap, and the vibration hammers microscopic chips out of the surface far faster than grinding ever could. It is the technique engineers reach for precisely when a material is too hard and too brittle for ordinary cutting. Ceramics, hardened steel, glass, semiconductors. And here is the part that connects it back to the stone. The granite of Egypt is more than half quartz. Quartz is not an ordinary mineral. Squeeze it, and it produces an electrical charge. Vibrate it at the right frequency, and it answers, ringing in sympathy. It is the crystal we use to keep time in a watch and to generate ultrasonic sound in the first place. Under a vibrating tool, the quartz inside the granite would not sit there as the hardest obstacle in the rock. It would resonate. It would join in, which is exactly the strange thing Petrie saw. The hardest mineral cut the deepest, because the hardest mineral was the one most eager to vibrate. The engineer who laid all of this out in detail, a man named Christopher Dunn, spent years arguing that the marks on Core 7 are the fingerprints of a vibratory, sound-based cutting process, a lost cousin of the ultrasonic machining we use today. If you find these buried mysteries as hard to let go of as I do, take a second to subscribe, because the next two clues are where a strange object turns into a strange civilization. There is one more piece that keeps the sound thread alive. The most famous room inside the Great Pyramid, the granite-lined chamber at its heart, is known to behave like an instrument. Stand inside it and speak, and the room answers. It rings. People who have measured its acoustics describe a space that amplifies certain deep frequencies with unusual power. A stone box that seems built to resonate. The Egyptians filled that room with the same quartz-heavy granite hauled all the way from the south, the same stone that answers to vibration, and shaped it into a chamber that hums. Whether they understood the physics the way we write it down today or not, they were clearly paying close attention to how hard stone and sound behave together. They were not afraid of resonance. They built with it. Mainstream Egyptology does not accept Dunn's conclusion, and we will come back to exactly why. But sit for a moment with what the object itself is doing. A mark that runs backwards through the crystal. A feed rate that unsettled the most careful measurer of his era. And the best modern match for both is a technique built on vibration, on sound, applied to the one common stone on Earth that answers to sound. Not a myth, not a metaphor. A groove in granite that behaves like the output of a machine we only recently learned to build. Now here is where it stops being one object. If this were a single freak core, you could shrug it off. One odd fragment, one careless reading, case closed. But the precision is everywhere, and it is enormous. Go south to Aswan, the quarry that supplied the hard stone for the greatest monuments, more than 500 miles up the river from Giza. Lying in the bedrock, there is a single block the Egyptians began to carve and never finished. It is called the Unfinished Obelisk. It is around 137 feet long. Had it been raised, it would have weighed somewhere between 1,100 and 1,200 tons. One stone. It was abandoned because a crack ran through it during the work, and that abandonment froze the whole process in place for us to study. Around it, you can still see the scoop marks and the rounded pounding balls of dolerite, the accepted method for bashing granite down towards shape. That part fits the textbook, but the ambition does not fit the picture of a primitive workshop. These people were carving a 1,200-ton needle out of living rock and fully expecting to stand it upright and point it at the sun. And it is not only the drilling. Inside that famous granite chamber in the Great Pyramid sits a box cut from a single block of dark stone. Its sides worked so straight and so square that engineers who have measured them still describe the flatness with a kind of unease. Petrie found something else on hard granite like this. Saw marks, long parallel scores left by a blade dragged through the rock, and from the length and curve of some of the cuts he measured, he inferred saws that would have had to be several feet long. A saw, several feet long, cutting granite. There are basalt paving slabs near the Great Pyramid carrying the same kind of straight kerf, a clean slot sliced right through the stone, the unmistakable track of a blade fed in a straight line. Sawing granite is, if anything, a harder problem than drilling it, because a saw has no single point to focus the pressure. It has to bite along its whole length at once. Whatever they were dragging through that stone, a plain copper blade alone does not do this. Copper is far softer than the quartz it was somehow slicing clean in half. Then look at the small things, which are somehow harder to explain than the enormous ones. From the very earliest periods of Egypt, before the Great Pyramids were even built, there are thousands of bowls and jars carved from granite, from diorite, from basalt, some of the hardest stones there are. A number of them are hollowed into closed, rounded shapes through necks so narrow you can barely fit a finger inside, with walls ground so thin that light passes through them when you hold them up. To hollow a sealed vessel out of a block of granite, evenly, symmetrically, through a tiny opening, is a task that would test a skilled craftsman today with modern tools. And they were turning them out in quantity, at the dawn of the civilization, not the height of it. Then there is a site near the old capital where rows of gigantic stone boxes sit underground, each one cut from a single block of granite, each weighing dozens of tons, with interior walls flattened and squared to a degree that visitors still travel there just to run their hands along the corners in disbelief. Whatever shaped that little core in London was not a one-time trick, pulled off once by a single genius. It was standard practice, repeated at every scale, from a cup-sized cylinder to a box heavier than a house, across the length of the country and across the centuries. The mainstream answer is time, labor, and patience. Thousands of workers, generations of accumulated skill, endless hours of grinding. And no one should ever underestimate what disciplined human labor can achieve. But patience does not explain the backwards groove, and it strains hard against the tolerances, the perfectly flat interiors, the thin, translucent vessel walls, the sheer repeatable volume of the hardest stone shaped to a standard. The more of it you see, the less it looks like slow rubbing, and the more it looks like a capability, a method, something they had and we do not. And this is where the story jumps straight into our own century, because until very recently, we had no real idea how much of this operation was even still out there. Then, modern eyes in orbit found something that changed the scale of everything. Starting around 2011, an American archaeologist named Sarah Parcak did to the whole of Egypt what Petrie had done to one plateau. She measured it. But she measured it from space. Her team pulled data from infrared satellites orbiting roughly 400 miles above the ground. Cameras sensitive enough to pick out features less than a single meter across. Buried mud brick holds moisture differently from the sand around it, and that difference shows up in the infrared, like a bruise beneath the skin of the desert. She was reading the ground for what no human eye on the surface could ever see. What came back was staggering. 17 buried pyramids, more than 1,000 lost tombs, more than 3,000 ancient settlements, most of them completely unknown, hidden under fields and sand. Teams on the ground began to dig where the satellites pointed and confirmed it, uncovering a previously unknown pyramid at a site everyone had assumed was already picked clean. The maps of ancient Egypt that filled our textbooks were not so much wrong as almost empty. Parcak has said plainly, that we have found only a fraction of 1% of what is still buried out there. And the satellites did more than count hidden pyramids. Remote sensing from above has been used to trace the quarries themselves and the long hauling roads that ran out from them across the desert, the arteries of a stoneworking operation that stretched for hundreds of miles. It confirms a pipeline. Stone cut in the far south, floated down the river, dragged overland, and finished at temple and pyramid sites the length of the country. And every single step of that pipeline depended on one thing we still cannot account for: the ability to cut the stone in the first place. You can move a block with enough rope and enough backs. Nobody doubts that. But you cannot bore a clean, tapered hole through granite with rope. You cannot saw it flat with rope. You cannot hollow it into a thin-walled bowl that passes light with rope. That took a tool. And that tool is the missing piece sitting at the center of the entire mystery. Now think about what that does to the drill core. Every hole, every box, every translucent bowl, every saw cut we have ever studied comes from that thin sliver of sites we have actually reached. The satellites confirmed that the workshop behind all of it was vastly larger than the handful of famous monuments we walk around today. This was not a rare feat performed a few times by a few masters. It was an industry, an entire civilization organized around shaping the hardest stone on Earth to a standard, at a scale we are only now beginning to grasp from orbit. And the tool that did the shaping is still missing from every single one of those sites. Which brings us to the strangest silence in this entire story. We have the cores, we have the holes, we have the boxes and the bowls, and a 1,200-ton obelisk lying in its quarry. We now have thousands of newly found sites waiting under the sand. What we do not have anywhere is the tool. Every drill bit, every saw, every cutting head that made these marks is gone, not rusted into a recognizable lump in a museum tray. Not painted on a single tomb wall among the thousands of scenes the Egyptians left of daily work, harvesting, brewing, building, hauling. The method that stamped its signature onto stone across an entire country left behind no surviving instrument and no written manual. And the one object that most clearly preserves the anomaly, that little grooved core, sat quietly in a museum drawer for over 100 years while the very detail Petrie flagged went largely undiscussed. When the anomaly was finally pushed back into the open, the response was not a clean answer. It was a fight over what the marks even are. Some specialists who examined the core insisted the spiral is not a spiral at all, just a series of separate concentric rings, the ordinary trace of a drill. Others pointed to old records describing cores ringed with as many as 17 continuous spiral turns. The object is public. Anyone can go and look at it. And yet, after more than a century, the field still cannot fully agree on what is carved into that stone, or on what carved it. The evidence sits under glass in London. The thing that made it is nowhere on Earth. So let me be honest with you, because this is where the wild version has to be put to the test. Does any of this prove a lost sound machine, some forgotten ultrasonic technology humming away in the workshops of the Nile? No, it does not. And the strongest reason to stay careful has a name. Denys Stocks spent much of his life on exactly this question, and not from an armchair. He worked with his hands. In the Aswan quarries, using copper tubes, dry quartz sand, and dolerite pounding balls, he reproduced the ancient techniques and cut real granite with them. It was slow, and it was punishing. In one experiment, his crew cut a slot about 95 centimeters long and a few centimeters deep, and it took them around 14 hours of steady work. The copper wore away, the sand did the biting, and the granite gave up its shape a little at a time. His point was simple and fair. The Egyptians had time, they had manpower, they had generations to perfect the motion. Given all of that, copper and sand and stone can, in fact, work granite. And other examiners of Core 7 argued that its groove is not the impossible spiral it is made out to be at all. Just ordinary concentric rings of the kind you find on drill cores in any modern quarry. Concede all of it. Concede that the obelisk was pounded out with dolerite. Concede that patient hands with sand and a copper tube can drill hard stone. That is real, and it belongs on the table. But here is what conceding all of it still cannot make ordinary. Strip away every wild theory, every machine, every lost civilization, and you are left with a set of plain facts that are stranger than the fantasy. The founder of scientific Egyptology, a meticulous engineer with no motive on earth to invent a mystery, looked at Core 7 and could not square a groove that cuts deeper through the hardest crystal than the soft one. And he said so in print for anyone to check. No replication has ever matched the feed rate, the depth, and the spiral consistency of that original core at the scale it was produced. The tolerances repeat across hundreds of miles and thousands of years. And the tool that made all of it has never been found. You do not need to believe in anything exotic to be unsettled by that. You just need to look at what is actually there. And if even the modest version of this is true, it says something uncomfortable about the story we tell ourselves. It means a people we quietly file under early, working supposedly with copper and stone, possessed a way of shaping the hardest rock on Earth that we can describe and measure, but still cannot fully reproduce. It means the marks on that core are not a curiosity, but a message, telling us there was a technique here that we have lost so completely we cannot even agree it existed. It means the satellites are right, and most of the evidence is still lying in the ground, unread, waiting. Our picture of the ancient world is not a finished portrait. It is a sketch with the single most important chapter torn out of it. And the question that started all of this is still standing, exactly where it started. What cut the stone? Not who built the pyramids, not how many workers hauled the blocks up the ramps. What was the actual tool, the actual method that plowed a spiral groove backwards through solid quartz and then disappeared so completely that it left its marks everywhere and its instrument nowhere? We can name a modern process that behaves like it. We cannot show you the ancient one, and no one alive can tell you where it went. The little cylinder of pink granite is still there, in its case in London, still wound with that impossible groove, still waiting for someone to explain it in a way that actually holds. The quarry at Aswan still cradles a 1,200-ton stone, frozen in the middle of being cut, the crack still running down its side. The thousands of sites the satellites found are still sealed under the sand, unexcavated, holding whatever they hold. And somewhere in all of it, or lost forever from all of it, is the one thing we have never recovered, the tool that shaped the stone. It left its signature on a whole civilization of rock in perfect, patient, backward spirals, and then it vanished. And it has never, not once, been found.